In this video, we are going to be talking about mass, volume, and density. So if you know some information on this stuff, that is great. If not, here's your chance to learn. So our goals for today are hopefully by the end of it, you're going to be able to explain mass, volume, and density. And you're also going to be able to calculate those three things. So let's start off with just talking about matter. So we know that all objects are made of matter. Your hair, your table, your fingernails, your floor, the air, everything. Matter is anything that has mass and takes up space. So we're going to be talking a little bit more about this in the next unit, but we know that there are three states of matter that we typically think about, and that's gas, liquids, and solids. So anything in those three forms is some type of matter. So which of these is not matter? You've got air, you've got your body, sound, and a table. So as I just told you, anything that is a gas, liquid, or solid is a matter. And I had also mentioned that air is matter because it's something that takes up space. Your body, well, that would be matter because that's something that takes up space. Sound, well, that doesn't really take up space because it just uses the air to travel. And tables, well, obviously we know those take up space. Sometimes they take up loads of space. So the one here that is not matter is going to be sound. So matter and mass. Different objects contain different amounts of matter. So mass is how much matter an object contains. So looking at my little pictures here, we've got a killer whale and a dog. Which one do you think has more mass? Well, your brain is probably thinking, well, obviously the killer whale. And you'd be right, because there's so much more matter packed inside that huge whale than there is inside that tiny dog. So think about it in the format of the larger the object, the more mass it has. So typically we measure mass in grams or kilograms. Metric system, we just learned about it. But what do we use to measure mass? Well, these two things pictured on the side here, generally we use those. If I'm having you do a lab at home, sometimes I'm going to have you use a food scale. That is just because you don't have access to these items. If you're in a general science class, you're going to use these two things, and we call these balances. Typically, we use electronic balances in my science classes, but sometimes we use triple beam balances. So this is the electronic balance, and this is the triple beam. They call this the triple beam because it has three arms here that is used for measuring the weight. So now let's talk about volume. Well, what is volume? This is the measurement of the amount of space an object takes up. So generally we measure this in milliliters or cubic centimeters. Again, metric units. But how do we measure volume? So those are the units we use, but how do we figure out how much volume an object has? Well, with liquids, we can just use a graduated cylinder or your liquid measuring cups at home. Or for solids, depending on the solid, we could use volume equations or water displacement. So for regular shaped objects like rectangles, cylinders, and circles, many other things, we can use the volume equations that we know from math class, or things that we can use the volume equations we know from math class. But for irregularly shaped objects, like a crazily jagged rock or half-eaten pizza, we would need to use water displacement. Now, putting your pizza in water would kind of be gross, but let's think about it with the rock. So water displacement, this is when we start off with a certain amount of water in our graduated cylinder or liquid measuring cup, put the object in, and then look at the amount the water went up, subtract the two numbers, and that gives us our volume for the object. So here are some regular shaped equations. We've got the volume of the cube, length times width times height. We've got a volume of a cylinder, which is pi r squared times height. And then we've got the volume of the sphere. This is 4 pi r cubed over 3. The one we're going to be using the most is this one here, because most of the questions that would require the equation are going to have to do with rectangles and cubes. So, like I was talking about with displacement, we put the water in the graduated cylinder without the object, so a starting amount of water, and you read that measurement. And then you put the object in the graduated cylinder, see how much the water goes up and read that. And then you're going to subtract the two numbers, and now you have the volume of your object. So one thing we cannot forget is to read at the meniscus. So if you don't know what the meniscus is, if you've ever looked at something, if you've ever looked at water in a graduated cylinder or in your liquid measuring cup, you'll notice that there's kind of like this weird looking line. I'll show you right here. So this right here, this weird looking line, that's the meniscus. And what's happening there is, due to surface tension with the water, it's bulging down because it's attracted to the sides. So when we read from our graduated cylinder and from our liquid measuring cups, we need to read at the bottom. We need to read at the bottom of this, so right down here. Because if we don't read at the bottom of that, then we're not going to get an accurate measurement. So let's try reading this graduated cylinder. What does it say? So if you look, the 50's down here, 60's up here. So that must mean it's in the 50's. You look at the increments and you see 4 notches between this one and the middle notch. So it must means it's going by 1 milliliter. So that must mean, looking at the bottom of the meniscus, which is right here, we're at about 56 milliliters. Now let's calculate some volumes. So what is the volume of a ball if the beginning level of the water is 40 milliliters, and after placing the ball inside the graduated cylinder, the water volume is now 65 milliliters? Well, for this problem, we're using water displacement. So that means we need to take our final water volume minus our initial water volume. Our final water volume is 65 milliliters. And we started out at 40 milliliters. So 65 minus 40, that should give us 25 milliliters for the volume of the ball. Let's try this one. So here, picture 1 is before the irregular shaped object goes inside the graduated cylinder. Picture 2 is after. So we need to do displacement again, so calculating the volume of the object by subtracting. And it looks like for the first one, for the final volume, we've got 9. So 9 milliliters. And for the initial, we've got 7. So 9 minus 7, that means this object has a volume of 2 milliliters. All right.